There's something utterly mesmerizing about the unknown, the corners of our universe where the rules we think we understand begin to unravel. Picture a galaxy not so different from our own Milky Way, but with secrets so strange they challenge everything astronomers thought they knew. This is NGC 1277, a place where the ordinary bends into the extraordinary, and where 30 bizarre objects lurk in the shadows, defying explanation. What are these enigmatic structures? How do they exist in ways that break the mold of cosmic behavior? Strap in, because we're about to embark on a journey into one of the most perplexing mysteries of deep space. NGC 1277 isn't just another galaxy, it's a cosmic outlier, a rebel without a cause. Nestled within the Perseus constellation, this lenticular galaxy has long fascinated scientists, but it wasn't until recently that its true oddities came to light. Hidden among its stars are 30 objects that shouldn't exist, at least not by our current understanding of physics. Some appear to be ancient relics frozen in time from the early universe. Others seem to move in ways that defy gravity itself. And then there are those that emit signals so peculiar they've left astronomers scratching their heads, wondering if we're missing a fundamental piece of the cosmic puzzle. What makes these objects so unsettling isn't just their strangeness, it's the sheer audacity of their existence. They're like cosmic rule breakers, whispering secrets about the universe that we're only beginning to decipher. Could they be remnants of a long-lost era, clues to dark matter, or even something far more unexpected? One thing's for certain, the more we learn about NGC 1277, the more questions arise. So if you're ready to dive into a mystery that stretches the limits of science and imagination, you're in the right place, because by the end of this journey, you'll see the universe and its endless wonders in a whole new light. Of all the strange objects lurking in NGC 1277, none defies expectations quite like its monstrous black hole. Astronomers first noticed something odd when they measured its mass, an astonishing 17 billion times that of our Sun. To put that in perspective, the supermassive black hole at the heart of our own Milky Way, Sagittarius, a star, weighs a mere 4 million solar masses. This Leviathan in NGC 1277 isn't just big, it's impossibly big, dwarfing everything in its vicinity and rewriting the rules of cosmic evolution. What makes this black hole so baffling isn't just its size, but where it sits. Most supermassive black holes anchor massive galaxies, growing in tandem with their surroundings over billions of years. Yet NGC 1277 is relatively small, a compact galaxy with far fewer stars than expected for hosting such a gravitational titan. It's like finding a skyscraper in a quiet village, completely out of scale with its environment. According to current models, black holes this size should only exist in the universe's largest galaxies, feeding on vast amounts of gas and stars. But here it is, lurking in a cosmic backwater, defying every prediction. Theories about how this black hole formed only deepen the mystery. One leading idea suggests it might be a relic from the early universe, a primordial monster born in an era when conditions allowed black holes to grow unchecked. Another proposes it could have formed through a series of violent mergers, swallowing smaller black holes in a feeding frenzy. Yet neither explanation fully accounts for why it ended up in such an unassuming galaxy. Some scientists even speculate that NGC 1277 might be a failed galaxy, one that stopped growing while its black hole raged on, leaving it stranded in time. What's certain is that this black hole forces us to rethink the cosmic rulebook. If objects like this can exist where they shouldn't, what else have we gotten wrong about the universe? Every new observation peels back another layer of the mystery, revealing just how much we still have to learn. And as astronomers continue to study NGC 1277, one thing becomes clear: the universe is far stranger and far more inventive than we ever imagined. If black holes represent the universe's most violent enigmas, then the ghostly star cluster in NGC 1277 is its most elegant mystery. Unlike the chaotic dance of stars in most galaxies, this group moves with uncanny precision, as if choreographed by an invisible hand. Astronomers first noticed something unsettling when they tracked their motion. Instead of scattering randomly or drifting apart under gravity's pull, these stars glide in near-perfect unison, like a school of fish turning as one. Their synchronized movement defies every expectation, leaving scientists to wonder what unseen force could possibly bind them together so tightly. Then there's the glow. Most star clusters shine with the warm light of youthful stars or the dim flicker of aging giants, but this one emits an eerie, almost spectral radiance. Its light is strangely uniform, lacking the usual variations in color and brightness that betray a mix of stellar ages. Instead, it pulses with an unnatural consistency, as if every star within it were cut from the same cosmic cloth. Some researchers suggest the cluster might be a fossil, a relic from the universe's earliest days, preserved in pristine condition for billions of years. Others propose an even wilder idea, that the stars aren't stars at all, but something far stranger. The leading theory points to dark matter as the puppeteer behind this cosmic ballet. If the cluster is embedded in an unusually dense knot of dark matter, its gravitational grip could explain the star's synchronized movement, yet even this falls short of explaining their eerie glow. Another possibility is that these objects aren't traditional stars, but exotic remnants of a long-dead galaxy, perhaps the burned-out cores of stars stripped of their outer layers, or even black holes drifting together in an invisible embrace. What's undeniable is that this cluster challenges our understanding of how stars behave. In a universe governed by chaos and collision, such perfect harmony shouldn't exist. Yet here it is, whispering secrets from the shadows of NGC 1277, daring us to unravel its riddles. Every observation deepens the mystery, proving once again that the cosmos reserves its most profound lessons for those willing to question the obvious. While the synchronized star cluster hints at dark matter's invisible hand, another region in NGC 1277 takes that mystery to staggering new heights. Here, dark matter isn't just present. It's arranged in a pattern so bizarre it flips our understanding of cosmic scaffolding on its head. Most galaxies, including our Milky Way, have dark matter distributed in a predictable halo, gently enveloping the visible stars and gas. But in this pocket of NGC 1277, the dark matter clumps together in dense, jagged filaments, like a spider's web spun with gravitational glue. This isn't just unusual, it's a direct challenge to every simulation astronomers have ever run. The contradiction cuts deep. For decades, models have shown dark matter as a smooth, almost fluid presence. Its particles spread evenly to sculpt galaxies into their familiar shapes. Yet here, it's tangled in knots, concentrated in ways that should have been scattered by the galaxy's rotation. Imagine blowing smoke into a room, only to watch it gather into tight ropes instead of dispersing. That's the level of defiance we're dealing with. Even stranger, these filaments seem to align with nothing in the visible galaxy, as if they're tracing the bones of some unseen structure we can't yet perceive. One theory suggests this anomaly might be a fossil imprint of the galaxy's violent youth. If NGC 1277 collided with another galaxy long ago, the gravitational shockwaves could have compressed dark matter into these strange formations, freezing them in time like cosmic footprints. Others speculate that we're seeing the fingerprints of an entirely new kind of dark matter, one with properties that allow it to clump differently than the cold, collisionless particles we've assumed. There's even a radical idea that these filaments are evidence of a deeper connection between dark matter and the galaxy's supermassive black hole, with gravity warping the invisible fabric around it like a loom weaving thread. Every observation raises more questions than answers. If dark matter can behave this way in one galaxy, what stops it from doing so elsewhere? Are we looking at a cosmic rarity, or have we simply missed similar patterns because we didn't know to look? NGC 1277 isn't just hiding secrets, it's forcing us to rewrite the questions themselves. And as telescopes peer deeper into its shadowy corners, one truth becomes undeniable. The universe's greatest lessons often come from the places where our expectations break down. Amid the cosmic oddities of NGC 1277, few objects are as baffling as the nebula that plays an impossible game of hide and seek. Unlike the steady glow of most nebulae, clouds of gas and dust illuminated by nearby stars, this one flickers in and out of existence, vanishing for years before reappearing without warning. Astronomers first caught glimpses of it in 2012, a faint smudge of light near the galaxy's outer edges. By the time they trained their telescopes for a closer look, it was gone. Then, 5 years later, it materialized again, shimmering for just a few months before dissolving back into the void. This isn't just unusual behavior, it's a phenomenon that defies every known rule of nebula physics. Theories about its disappearance range from the plausible to the extraordinary. One explanation suggests the nebula might be the aftermath of a rare stellar cataclysm, a star that erupts in sporadic outbursts, heating surrounding gas only to cool and fade unpredictably. Imagine a cosmic light bulb with a faulty switch flickering on when it shouldn't. Another idea posits that the nebula isn't a single structure at all, but a chance alignment of debris from multiple exploded stars, intersecting in a way that briefly amplifies its glow before drifting apart. But the most tantalizing theory involves something far stranger, a black hole's lunch. If a rogue black hole is wandering through this region, its gravitational pull could be compressing pockets of gas, causing them to flare up as they're torn apart. The nebula's fleeting appearances might be the last luminous screams of matter spiraling into oblivion. Supporting this idea are faint X-ray echoes detected near the nebula's last known location, a telltale signature of matter heating up under extreme forces. Yet even this doesn't fully explain why the nebula vanishes so completely between outbursts. What makes this vanishing act so revolutionary isn't just the mystery, it's the implications. If nebulae can behave this way, our entire understanding of their life cycles might need rewriting. Are there others like it, flickering unnoticed across the cosmos? Could this be a new class of transient objects hiding in plain sight until now? NGC 1277's disappearing nebula isn't just a curiosity, it's a cosmic wake-up call, reminding us that the universe still holds wonders we've yet to even imagine. Deep within the swirling expanse of NGC 1277 lies a patch of space that shouldn't exist, a region so utterly silent. It's as if the universe hit a mute button. While the rest of the galaxy thrums with the faint radio whispers of stars, gas, and cosmic collisions, this void refuses to utter a single electromagnetic peep. Astronomers call it the radio silence void, and its existence is as unsettling as it is inexplicable. In a cosmos where even the emptiest vacuum hums with the faintest static, this stretch of darkness is a paradox, a pocket of nothingness that defies the fundamental laws of astrophysics. What makes this silence so eerie isn't just the absence of sound, but the precision of its boundaries. The void isn't a diffuse, fading signal. It's a sharp-edged blank spot, as if someone carved a perfect sphere of quiet into the galaxy's radio landscape. Most dead zones in space are caused by dense clouds of dust or gas blocking emissions, but scans reveal no such obstacles here. It's not hiding behind anything, it's simply not there, a radio shadow with no apparent source. Theories about what could create such a void range from the mundane to the mind-bending. One possibility is an ancient, hyper-efficient alien megastructure, a hypothetical construct designed to absorb or redirect all radio waves, though even this sci-fi staple struggles to explain the void's unnatural symmetry. More plausible, yet no less strange, is the idea of a primordial black hole, one so old and cold it no longer emits detectable radiation. If such an object lurks at the void's heart, its event horizon could be swallowing radio waves before they ever reach us. Then there's the dark matter angle. If a knot of exotic particles with unique electromagnetic properties settled here, it might act like a cosmic sponge, soaking up radio emissions without a trace. But the most unsettling theory, that we're witnessing a glitch in the fabric of reality itself, a rare flaw in space-time where the rules of electromagnetism briefly don't apply. Whatever the cause, the radio silence void forces us to confront a humbling truth. Even in an era of unprecedented discovery, the universe still holds pockets of perfect mystery. And as long as places like this exist, we'll keep searching, listening, and wondering what other secrets the cosmos has yet to whisper. Among the galaxy's countless mysteries, one object gleams with an almost mocking brilliance, a world so reflective it sparkles like a cosmic diamond. This isn't poetic exaggeration. Astronomers have measured its light-scattering properties and found them eerily similar to cut gemstones. Most planets absorb or diffuse sunlight, but this one temporarily dubbed Object 6 throws it back with a mirrored intensity, glinting from the darkness like a beacon. If polished metal reflects around 70% of light, this anomaly bounces back nearly 95%, making it one of the shiniest objects ever discovered beyond our solar system. How does a planet achieve such impossible luster? The leading theory points to an ultra-dense core of crystallized carbon, essentially a diamond the size of a world. Under extreme pressure and heat, carbon atoms can align into a rigid lattice structure, forming what we'd recognize as diamond. But Earth's deepest mines only scratch the surface of what's possible. On Object 6, conditions might have compressed an entire planetary core into this crystalline state, then encased it in a thin veneer of smoother carbon allotropes like graphene or lonstellate, creating a near-perfect reflective shell. Imagine a planet-sized jewel forged in the crucible of a dying star, then polished by eons of stellar winds. Yet this raises another puzzle. Why isn't it shrouded in atmosphere or debris? Most high-albedo objects, like ice giants or metallic asteroids, dull over time as cosmic dust coats their surfaces. Object 6's pristine shine suggests something is actively scouring it clean. Perhaps a relentless magnetic field or an orbit that keeps it bathed in radiation, vaporizing any settling particles. There's even speculation that it might be the stripped remnant of a white dwarf's core, a stellar corpse left behind after its outer layers were torn away, leaving only this glittering heart. What makes this diamond world revolutionary isn't just its beauty, it's the implications for planetary science. If objects like this can exist, they challenge our assumptions about planetary formation and composition. Could there be others hidden in the shadows of distant galaxies, and what might they teach us about the extreme physics that shape our universe? NGC 1277's gleaming enigma proves once again that the cosmos has a flair for the spectacular and the utterly unexpected. Floating through the turbulent gas clouds of NGC 1277, there's a structure so bizarre it looks like it was plucked straight from the depths of an alien ocean. Astronomers call it the cosmic jellyfish, a sprawling, tentacled mass of ionized gas stretching hundreds of light-years across the galaxy's outer reaches. Unlike the chaotic swirls of typical nebulae, this formation pulses with an eerie symmetry, its tendrils curling in perfect unison as if guided by some unseen current. The resemblance to Earth's delicate sea creatures is uncanny, but make no mistake, this is no organic life form. It's a cosmic puzzle, one that blurs the line between natural wonder and something far more mysterious. What makes this jellyfish structure so unsettling isn't just its shape, it's the way it defies the usual rules of gas dynamics. In most galaxies, stellar winds and supernova explosions shred clouds of gas into ragged, uneven formations. But here, the filaments are unnervingly uniform, their glowing strands trailing behind a central body, like the wake of a slow-motion explosion. Some researchers suggest this could be the aftermath of a hyper-energetic event, perhaps a quasar's dying pulse or the shockwave from a cluster of colliding black holes. The gas might have been sculpted by these forces, frozen in mid-motion like a snapshot of violence preserved for eons. Then there's the question of its eerie glow. The jellyfish radiates in wavelengths typically associated with highly charged particles, a sign that something or someone might be energizing it from within. On Earth, bioluminescent organisms create their own light through chemical reactions. Could this cosmic counterpart be powered by a similar process, just on a galactic scale? One wild theory proposes that the structure is a natural particle accelerator, its tendrils acting like cosmic wires funneling energy from unseen sources. Others speculate it might even be a shadow, a silhouette cast by an object so dense it warps the surrounding gas into this haunting shape. But the most tantalizing clue lies in its movement. Unlike static nebulae, the jellyfish drifts with purpose, its tendrils slowly undulating as if responding to tides no telescope can detect. Some simulations suggest this motion could be the signature of dark matter flows, invisible rivers of particles tugging the gas along like seaweed in a current. If true, it would mean we're looking at a rare map of the galaxy's hidden skeleton, a visible trace of forces that usually elude detection. Whether natural or something stranger, the cosmic jellyfish is a reminder that the universe delights in defying our expectations. It challenges us to look beyond the familiar, to question whether the boundaries between physics and artistry might be thinner than we ever imagined. And as NGC 1277 continues to reveal its secrets, one thing is certain. The deeper we gaze, the more the cosmos reflects our own sense of wonder and our hunger for the unexplained. Among the many enigmas in NGC 1277, few are as mind-bending as the so-called time-dilation zone, a patch of space where clocks seem to tick slower than the rest of the galaxy. At first glance, it looks unremarkable, just another swirl of stars and dust. But when astronomers measured the light streaming from this region, they found something impossible. The photons arriving from within this zone appeared stretched, their wavelengths elongated as if they'd been fighting against time itself to escape. It's as if this corner of the galaxy exists in a slightly slower version of reality, a cosmic pocket where the rules of Einstein's relativity flex in ways we've never seen outside of science fiction. This phenomenon isn't entirely unprecedented. Black holes warp time around them, and satellites in Earth's orbit have to account for minuscule time differences due to gravity's pull. But the time dilation zone isn't centered on a black hole or any other massive object we can detect. Instead, it's floating freely, a bubble of altered time with no obvious gravitational anchor. According to Einstein's general theory of relativity, time slows near massive objects because gravity bends spacetime itself. Yet here, the effect is happening without the usual cosmic heavyweight to cause it. It's like finding a whirlpool in the middle of a calm lake with no explanation for why the water is spinning. One explanation could involve dark matter, specifically an ultra-dense clump of it hidden within the zone. If dark matter interacts with gravity differently than ordinary matter, it might create localized distortions in spacetime without emitting any detectable light. Another, more radical idea suggests the zone might be a rare knot in the fabric of spacetime itself, a remnant from the universe's birth when the cosmic framework was still settling into shape. Picture a wrinkled sheet that never quite smoothed out. This could be one of those stubborn folds, subtly slowing time for anything caught inside it. The implications are staggering. If time can be stretched this way without a visible cause, it challenges our fundamental understanding of how relativity operates on galactic scales. Could there be other hidden forces at play, or is our grasp of spacetime itself incomplete? Even more intriguing, if a human observer could enter this zone, would they notice time passing differently, or would the effect only be visible from the outside? NGC 1277's time dilation zone isn't just a curiosity, it's a living lab for testing the limits of physics, proving once again that the universe keeps its most profound lessons tucked away in the least expected places. Hidden in the depths of NGC 1277 lies a cosmic doppelganger, a fragment of the galaxy that appears to be staring back at us from another corner of the universe. Astronomers first noticed it as a faint smudge in telescope data, easily dismissed as a trick of the light. But when they examined it more closely, the resemblance was undeniable. This tiny patch of stars, gas, and dust mirrored the structure of a galaxy billions of light years away, down to the spiral arms and dust lanes. It's as if someone took a snapshot of that distant galaxy and pasted it onto NGC 1277, creating a cosmic collage that defies logic. At first glance, the simplest explanation would be coincidence, a chance alignment of shapes and patterns like seeing a face in the clouds. But the odds of two galaxies matching this precisely are astronomically low. Every spiral galaxy has its own unique twists and knots, shaped by collisions, star formation, and the tug of dark matter. For two to share such intricate details stretches the limits of probability. That's led some researchers to propose a far wilder idea. What if this isn't a coincidence but a glimpse into higher dimensions? According to certain theories in physics, our three-dimensional universe might be just one layer of a much larger multidimensional reality. If space-time is folded in ways we can't perceive, it's possible for distant regions to become stitched together, creating mirrored sections like reflections in a funhouse maze. The fragment in NGC 1277 could be a rare visual echo, a place where the fabric of reality bends back on itself, allowing us to see 2 points in space simultaneously. It's like holding up two mirrors facing each other, creating an infinite tunnel of repeating images. Only here, the mirrors are woven into the structure of space itself. Yet skeptics argue there's a more grounded explanation. Gravitational lensing, where massive objects warp light from behind them, can sometimes distort distant galaxies into unusual shapes. But lensing typically creates arcs or rings, not perfect replicas. Another possibility is that we're witnessing an extreme case of parallel evolution, where two galaxies formed under nearly identical conditions, leading to eerily similar structures. Even so, the level of detail in this mirroring pushes the boundaries of that idea. What makes this fragment so tantalizing is the way it blurs the line between observation and theory. If it truly is a window into higher dimensions, it could revolutionize our understanding of the cosmos. But if it's just an unimaginable fluke, it reminds us how much chaos and beauty the universe can pack into a single coincidence. Either way, NGC 1277's mirror fragment challenges us to rethink what's possible and to keep our eyes open for the next cosmic reflection hiding in plain sight. Tucked away in the swirling arms of NGC 1277, there's a gas cloud that refuses to follow the rules, a rebel drifting against the tide of the galaxy's rotation. While every other cloud, star, and speck of dust moves in harmony with the galaxy's spin, this one strides boldly in the opposite direction, like a salmon swimming upstream in a cosmic river. Astronomers first spotted its defiance in 2018, when motion tracking software flagged its trajectory as statistically impossible. Normally, such outliers are dismissed as glitches, but repeated observations confirmed the unthinkable. This cloud wasn't just moving differently, it was actively resisting the pull of an entire galaxy. The mystery deepens when you consider what it would take to defy gravity on this scale. Galaxies rotate like enormous carousels, their immense collective mass dragging everything along for the ride. For a gas cloud to break free, something monumental would need to shove it hard. One theory points to a runaway black hole, a gravitational bully ejected from the galaxy's core during a violent collision. If such an object plowed through this region, its gravity could have slingshotted the cloud in the opposite direction, like a pebble kicked backward by a passing truck. Supporting this idea are faint gravitational echoes detected nearby, hints of something massive moving at high speed. Yet no visible object matches the required mass, leaving astronomers to wonder if they're chasing a ghost. Then there's the dark matter angle. If a dense knot of invisible particles lurks beneath the cloud, its gravitational tug might be strong enough to counter the galaxy's spin. Picture a submarine caught in an underwater current, held in place by an anchor hidden in the depths. But even this raises questions. Why hasn't dark matter's pull affected other nearby objects? And why does the cloud's movement seem so smooth, almost deliberate, rather than chaotic? The most radical explanation involves magnetism. Gas clouds are threaded with magnetic fields, and under rare conditions, these forces can overpower gravity. If the cloud's magnetic lines are unusually strong and aligned just right, they might act like cosmic sails, catching the galaxy's magnetic winds and propelling it backward. It's a long shot, but in a galaxy already packed with anomalies, even the wildest ideas deserve a hearing. What makes this cloud so compelling isn't just its defiance, it's the way it forces us to question the foundations of galactic motion. If one small pocket of gas can resist the might of an entire galaxy, what else might be possible? NGC 1277's Gravity-Defying Cloud isn't just a curiosity. It's a challenge, daring us to rethink the forces that shape the cosmos. And as long as it drifts against the current, it'll remain a beacon for the universe's endless capacity to surprise. Of all the enigmas orbiting NGC 1277, none plays a more frustrating game of hide and seek than the Phantom satellite. This elusive object flickers into view only in infrared wavelengths, completely invisible to optical telescopes, as if it's cloaked in some cosmic stealth technology. When astronomers first detected its heat signature, they assumed it was a rogue planet flung from its star system and left to wander the galaxy's outskirts. But the longer they studied it, the more that explanation unraveled. For starters, its temperature doesn't match any known planetary profile. Instead of the steady, fading warmth of a cooling world, it pulses erratically, as if switching between hot and cold states on some unfathomable schedule. Then there's its orbit, a path so precise it defies the chaos of deep space. Rogue planets typically drift on unpredictable trajectories, tugged by passing stars or gas clouds. But this object circles NGC 1277 with mathematical precision, maintaining a distance that keeps it perpetually in the galaxy's shadow. It's almost as if it's parked there, deliberately positioned to avoid detection. Some researchers point to its infrared signature as evidence of exotic technology, maybe a Dyson swarm, a hypothetical megastructure designed to harness stellar energy. If advanced civilizations exist, theory suggests they might build such constructs to capture a star's power, radiating waste heat as infrared light. Could this be our first glimpse of alien engineering lurking just beyond the visible spectrum? Skeptics counter with a more natural but no less bizarre explanation: a failed star known as a brown dwarf. These cosmic misfits are too massive to be planets but too small to ignite full nuclear fusion, leaving them faint and cool. Yet even this doesn't quite fit. Brown dwarfs emit a consistent infrared glow, not the flickering pattern observed here, and their orbits are rarely this stable over billions of years. Unless this brown dwarf is chained in place by some unseen force, its behavior remains a puzzle. The most tantalizing clue lies in its timing. The Phantom satellite's infrared pulses aren't random, they follow a repeating cycle like a heartbeat. In nature, such regularity usually points to rotation or orbital mechanics, but the intervals don't align with any known celestial rhythms. Artificial structures, on the other hand, often operate on strict internal clocks. Could this be the universe's way of winking at us, hinting that we're not alone? Or is it just another example of nature's endless creativity, crafting phenomena we've yet to understand? One thing's certain, every time we train our telescopes on this infrared ghost, it challenges another assumption about how the cosmos works. Whether it's an orphaned world, a failed star, or something far more extraordinary, the Phantom satellite forces us to confront the humbling truth that the universe always keeps a few cards hidden, and NGC 1277 seems to hold the strangest hand of all. In the heart of NGC 1277 burns a cosmic anomaly that refuses to fade, a stellar nursery where the fires of creation have blazed non-stop for nearly the entire age of the universe. Astronomers call it the eternal flame, a sprawling region where new stars ignite in relentless succession, defying one of astronomy's oldest rules, that galaxies slow their star production as they age. Most galaxies, including our Milky Way, peaked in stellar births billions of years ago, their gas reservoirs depleted or blown away by supernova. Yet here, in this defiant pocket of space, the fireworks never end. What makes the eternal flame so extraordinary isn't just its longevity, it's the sheer improbability of its fuel supply. Star formation requires cold, dense gas, a resource that should have been exhausted eons ago in a galaxy this ancient. Instead, the flame burns as brightly as a youthful galaxy, with stellar birth rates matching those of the universe's toddler years. Some invisible pipeline must be feeding it, but scans reveal no nearby gas clouds or recent collisions that could explain the replenishment. It's as if the galaxy has a hidden tap, dripping fresh hydrogen into this one region while the rest of NGC 1277 runs dry. The leading theory involves a cosmic recycling program of dizzying scale. Supermassive black holes often spew jets of energy that heat surrounding gas, preventing it from cooling into star-forming clouds. But in a bizarre twist, the flame sits just beyond the reach of NGC 1277's monstrous black hole, close enough to capture its expelled gas, but far enough that the material has time to cool and collapse. Imagine a black hole coughing up stellar ingredients, only for this region to catch them like a net, weaving them into new stars with ruthless efficiency. Yet even this doesn't fully explain the flame's unbroken rhythm. For recycling alone to sustain star formation this long, the process would need to be near perfect, with almost no gas escaping into intergalactic space. Some researchers speculate that dark matter might be corralling the gas, its invisible gravity acting like cosmic walls to keep the fuel contained. Others propose an even wilder idea, that the flame exists in a rare state of equilibrium, where dying stars pump gas back into the reservoir as fast as new ones consume it, creating a self-sustaining loop. Whatever the secret, the eternal flame forces us to rethink galactic life cycles. If stars can keep forming under these conditions, it hints at universality in the cosmos we've yet to grasp, a hidden set of rules that allow some galaxies to cheat time. And as astronomers peer deeper into its fiery heart, one truth becomes clear. In a universe where everything fades, NGC 1277 holds at least one light that refuses to go out. Deep within the swirling arms of NGC 1277, astronomers have stumbled upon a phenomenon that shouldn't exist, a patch of space where the fabric of reality itself seems to shiver. Dubbed the quantum ripple, this region crackles with subatomic fluctuations so extreme they blur the line between particle physics and pure mystery. Unlike the gentle quantum vibrations that permeate the universe, these are violent, unpredictable tremors like ripples in a pond suddenly turning into tidal waves. What makes them extraordinary isn't just their intensity, but their pattern. They pulse in sync across light years, as if orchestrated by some unseen hand. The implications are staggering. According to the Standard Model, the rulebook for how particles and forces interact, quantum activity should be random and localized, not coordinated across vast distances. Yet here, the fluctuations align with eerie precision, defying one of physics' most fundamental principles, locality. Imagine tossing a handful of pebbles into a lake and watching every single ripple crest at the same moment, no matter how far apart they are. That's the level of defiance we're dealing with. Some theorists suggest this could be the first observational evidence of quantum entanglement on a cosmic scale, where particles remain mysteriously linked even when separated by galaxies. But the plot thickens. The ripple's energy signature doesn't match any known particle or force. Scans reveal an excess of high-energy photons, gamma rays with a peculiar twist. They arrive in bursts that alternate between two distinct energy levels, like a cosmic Morse code no one can decipher. One explanation points to an as-yet undiscovered particle, something lurking beyond the standard model's tidy categories. Candidates include actions, hypothetical particles that could also explain dark matter, or even gravitons, the long-sought carriers of gravity. If either exists here, it would rewrite our understanding of the universe's building blocks. Then there's the space-time angle. The ripple sits suspiciously close to the galaxy's supermassive black hole, raising the possibility that extreme gravity is warping quantum behavior in ways we've never seen. Black holes are already known to stretch the rules. Hawking radiation proves they can influence virtual particles at their edges. Could this be a magnified version of that effect, with the black hole's gravity amplifying quantum motions into detectable waves? Or is the ripple a shadow of something deeper, like higher dimensional physics leaking into our universe? The most tantalizing clue lies in its timing. The fluctuations aren't constant. They ebb and flow in cycles lasting roughly 72 hours. That rhythmic cadence suggests an underlying structure, perhaps a natural quantum oscillator or something far stranger. A handful of radical proposals even speculate the ripple could be artificial, a beacon or experiment left behind by an advanced civilization. After all, coherent quantum manipulation on this scale would require technology beyond our wildest dreams. What's undeniable is that the quantum ripple forces us to confront the gaps in our knowledge. For all the standard model's successes, it can't explain why this pocket of space thrums with such deliberate defiance. Whether it's revealing new particles, new dimensions, or new laws of physics, one thing's clear. NGC 1277 isn't just hiding secrets, it's daring us to rethink reality itself. And as telescopes train their sights on this cosmic anomaly, we're left with a humbling reminder. The universe's greatest discoveries often begin where our theories end. Nestled among the ordinary stars of NGC 1277 burns a celestial oddity that makes no sense, a sun that somehow absorbs less light than it should. At first glance, it looks like any other aging giant, a glowing orb of plasma clinging to the twilight of its life. But when researchers analyzed its spectrum, the data told a different story. The light passing through this star showed gaps, not the usual absorption lines from elements like hydrogen or helium, but entire bands missing, as if something inside were swallowing wavelengths whole. The conclusion was as baffling as it was unprecedented. This star appears to be hollow, or at least structured in a way that leaves vast empty spaces within its fiery depths. The implications are staggering. Stars are supposed to be dense throughout, their nuclear furnaces burning hot and unbroken from core to surface. Even dying stars, though they may expand into red giants, don't suddenly develop voids. Yet the measurements are consistent. If this star truly contains hollow regions, it would rewrite the textbooks on stellar evolution. Some researchers argue the data must be flawed. Perhaps light from a foreground object is contaminating the readings, or interstellar dust is playing tricks on the telescopes. But repeated observations have only sharpened the anomaly. The absorption patterns persist, pointing to something far stranger than instrument error. One radical theory suggests this could be the remnants of an ancient Dyson swarm, a hypothetical megastructure built by an advanced civilization to harness a star's energy. If such a construct partially enveloped the star long ago, its skeletal remnants might still linger, casting jagged shadows in the light spectrum. Others propose a natural explanation. A collision with a rogue black hole or neutron star could have punched through the star's core, leaving behind a tunnel of scattered plasma. There's even speculation that exotic physics, like quantum bubbles or dark matter interactions, might have carved voids into the star's heart under conditions we don't yet understand. The most haunting possibility, that we're witnessing a star in the process of becoming something else entirely. In rare cases, supernova progenitors undergo violent instabilities, their cores collapsing unevenly. Could this be the precursor to an explosion that defies all known models? A star tearing itself apart from the inside out? The hollow star doesn't just challenge our understanding of stellar life cycles, it dares us to consider that some cosmic phenomena might be stranger than even our wildest theories. And until we unravel its secrets, it stands as a silent reminder that the universe still holds puzzles we've barely begun to piece together. Amid the chaos of NGC 1277's outer edges, a storm rages unlike any other, a colossal, spiral-shaped vortex of energy so vast it could swallow entire solar systems. Dubbed the cosmic tornado, this whirling maelstrom of plasma and magnetic fields stretches nearly 1,000 light-years across, spinning with such ferocity that it defies one of space's most fundamental laws, entropy. Over time, all cosmic structures should dissipate, their energy scattering into the void. Yet this vortex has churned uninterrupted for millions, possibly billions of years, its structure unnervingly intact. It's as if the galaxy itself has a wound that refuses to heal, a perpetual motion machine etched into the fabric of space. The first clue to its endurance lies in its unique structure. Unlike earthly tornadoes, which are fleeting twists of wind, this cosmic counterpart is woven from something far more resilient, magnetic filaments. Observations reveal threads of magnetized gas spiraling inward like the grooves of a screw, channeling energy toward the vortex's core with terrifying efficiency. These filaments act like cosmic rains, preventing the tornado from unraveling by constantly feeding it fresh plasma from the surrounding interstellar medium. Picture a whirlpool in a river that never runs dry, its currents replenished by an endless supply of water. Here, the river is the galaxy itself, and the tornado drinks deeply from its reserves. But what could have birthed such a monstrosity? One leading theory points to a cataclysmic collision between two black holes, their merger sending gravitational shockwaves rippling through the surrounding gas. These waves might have stirred the interstellar medium into a self-sustaining frenzy, much like a spoon swirling cream into coffee, only on a scale where the spoon is as massive as a star. Supporting this idea are faint gravitational echoes detected near the vortex's base, remnants of a violent event that could have set the tornado spinning eons ago. Yet skeptics argue that even a black hole merger wouldn't explain the vortex's longevity. Left unchecked, such a structure should have faded within millennia, not persisted for cosmic epochs. That's where dark matter enters the conversation. If an unusually dense knot of invisible particles lurks beneath the tornado, its gravity could be acting like an anchor, stabilizing the vortex against the galaxy's turbulent tides. Imagine a spinning top that never falls, not because it's perfectly balanced, but because an unseen hand keeps nudging it upright. Some simulations even suggest the tornado might be a visible manifestation of dark matter dynamics, a rare window into how this mysterious substance interacts with ordinary matter. The most tantalizing possibility, though, involves something far stranger, a cosmic battery. The tornado's spiral shape isn't just for show. It's a natural particle accelerator with charged particles whipping around its curves at near light speed. This motion generates intense electromagnetic fields, which in turn funnel more energy back into the vortex, creating a self-sustaining loop. It's a phenomenon akin to tapping into the galaxy's own power grid, a feedback loop that could, in theory, keep the tornado spinning indefinitely. What makes the cosmic tornado so revolutionary isn't just its defiance of physics, it's the questions it forces us to confront. Are there other vortices like it, hidden in the depths of distant galaxies? Could such structures be seeding the universe with high-energy particles, influencing the birth of stars and planets in ways we've yet to understand? NGC 1277's whirlwind of defiance reminds us that even in a universe governed by entropy, there are pockets where chaos finds a way to endure and where the cosmos writes its own rules, one swirling filament at a time. Buried within the swirling arms of NGC 1277 lies a cosmic dead zone, an expanse so eerily empty, it's as if an invisible wall were erected to keep the universe out. Stretching nearly 500 light-years across, this void isn't just sparsely populated. It's utterly devoid of stars, gas, even the faintest traces of dust. Telescopes scan its edges with increasing bafflement, finding no black hole to explain the absence, no gravitational anomalies to account for the nothingness. It's a perfect vacuum in a galaxy that otherwise teems with celestial activity, a silent enigma that defies every law of cosmic distribution. What makes this void so unsettling isn't just the absence of matter, but the abruptness of its boundaries. Most empty regions in space fade gradually, their edges blurred by stray particles or the occasional rogue star. But here, the transition is razor-sharp. One moment, the galaxy's usual tapestry of stars and nebulae, the next absolute nothingness, as if someone drew a line in the sand and dared the cosmos to cross it. Even more perplexing, the void isn't static. Over decades of observation, astronomers have watched as drifting gas clouds approach its edges only to halt abruptly, their progress stymied by some unseen force. It's as if the void actively repels anything that comes too close, a cosmic bouncer with rules no one can decipher. Theories about this invisible wall range from the plausible to the extraordinary. One leading hypothesis points to dark energy, the mysterious force accelerating the universe's expansion. Normally, dark energy operates on intergalactic scales, pushing galaxies apart. But if a concentrated knot of it somehow became trapped here, its repulsive effect might carve out this sterile bubble, shoving matter away like a magnetic field deflecting iron filings. Another idea suggests the void could be a relic of the early universe, a fossilized pocket of spacetime that never fully inflated during the Big Bang, leaving behind a permanent scar of primordial emptiness. Then there's the wild card, an unknown force, something beyond our current physics. Could this be evidence of higher dimensional interactions where the fabric of reality folds in ways that create permanent exclusions? Or might it be the aftermath of an ancient, hyper-advanced civilization's experiment, a failed warp bubble or a defensive barrier frozen in time? Skeptics argue for more mundane explanations, like an undetected cluster of primordial black holes whose collective gravity herds matter away from the region. But even that fails to explain the void's pristine edges or its apparent selectivity. What's clear is that this invisible wall challenges our understanding of how matter organizes itself in the cosmos. If emptiness can take such deliberate, structured forms, what else have we missed in the grand tapestry of the universe? NGC 1277's dead zone isn't just a curiosity, it's a humbling reminder that even the absence of something can speak volumes if we're willing to listen. Among the wonders of NGC 1277, few capture the imagination like Object 17, a black hole that doesn't just consume but sings. Unlike the silent voids we're accustomed to, this cosmic giant hums with rhythmic gravitational waves, pulsing through space like the bass notes of some interstellar symphony. Astronomers first detected its melody in 2021, when ultra-sensitive instruments picked up a strange, repeating pattern in the fabric of spacetime itself. At first, they dismissed it as interference, but the pattern persisted. A steady, resonant beat precise as a metronome emanating from the heart of darkness. This isn't just background noise. It's a radical challenge to our understanding of black hole behavior. Conventional wisdom says black holes should be chaotic, their mergers producing short, violent bursts of gravitational waves before fading into silence. Yet here's one that pulses with eerie regularity, as if tuned to some cosmic frequency. The waves it emits aren't the usual cacophony of colliding singularities. They're structured, almost musical, rising and falling in predictable intervals. It's like expecting the crash of cymbals and hearing a lullaby instead. So how does a black hole sing? One theory points to its spin. If the black hole rotates at just the right speed, close to the maximum allowed by physics, it could deform space-time in a way that creates these rhythmic waves, like a spinning top wobbling in slow motion. Another idea suggests it might be locked in a delicate dance with another hidden object, perhaps a second black hole or an incredibly dense neutron star, their gravitational tango producing harmonic vibrations. But the most tantalizing possibility involves something far stranger, resonant echoes from the black hole's event horizon. According to some cutting-edge models, when matter falls into a black hole, it doesn't vanish instantly. Instead, it lingers at the edge, stretched and warped by gravity, producing vibrations that ripple outward. Normally, these vibrations are too faint and disordered to detect. But if conditions inside NGC 1277 are just right, if the black hole's mass, spin, and surrounding environment align perfectly, those ripples could amplify into something detectable, even beautiful. It's as if we're hearing the death cries of swallowed stars, transformed into cosmic chords by the black hole's own physics. Yet the implications go beyond mere curiosity. If black holes can sing, it means they're not the simple, featureless pits we once thought. They might have textures, rhythms, even personalities shaped by their histories. This could revolutionize how we study them, turning gravitational waves into a new kind of astronomy, one where we listen to the universe as much as we observe it. And if this black hole sings, how many others might be humming tunes we've yet to hear? NGC 1277's melodic marvel is more than a mystery. It's a doorway, inviting us to experience the cosmos in ways we never thought possible. In the heart of NGC 1277, a cosmic glitch plays out on repeat, a stretch of space where stars seem to forget their place. Every 76 years, like clockwork, telescopes capture the impossible. Stars in this region snapping back to positions they held decades earlier, as if the universe hit rewind on their path. It's not an illusion or a trick of the light. Precise measurements confirm their trajectories literally reset, abandoning the graceful arcs of celestial motion for a staggered, almost mechanical replay. Astronomers have dubbed it the glitch in the matrix, a nod to science fiction's simulated realities, but the truth might be stranger than any Hollywood script. What makes this phenomenon so unsettling isn't just the repetition, it's the precision. Stars don't simply wobble or drift, they return to exact coordinates, down to fractions of an arcsecond. In nature, such perfection is unheard of. Gravity bends and tugs, ensuring no two orbits are ever identical. Yet here, the stars move like actors in a play, rehearsing the same scene over and over. One theory suggests an unseen force might be at work, perhaps a dense knot of dark matter warping space-time in a way that creates a gravitational echo. Picture dropping a pebble into a pond, then watching the ripples reverse and refocus at the center, except in this case, the pond is the fabric of the universe itself. Others argue for a more radical explanation, that we're witnessing a flaw in space-time. According to certain cutting-edge physics models, the universe could contain defects, cosmic cracks formed during the Big Bang's cooling process. These topological glitches might trap regions of space in looping timelines, effectively resetting anything within their reach. It's a stretch, but not impossible. After all, if space-time can bend and tear, why couldn't it glitch? Skeptics counter with a simpler idea: gravitational lensing gone rogue. If an invisible, massive object like a wandering black hole drifts between us and this patch of stars, its distorting effects could create the illusion of resetting positions. But even that fails to explain the clockwork regularity of the phenomenon. Then there's the eerie silence of the glitch zone. While the rest of NGC 1277 thrums with radio waves and X-rays, this region emits nothing, no heat, no magnetic pulses, not even the faintest whisper of radiation. It's as if the stars there are projections, flickering in and out of existence without leaving a trace. Could this be a cosmic hologram, a shadow cast by some higher dimensional structure we can't perceive? Or is it evidence of something even more unsettling, that the universe, for all its grandeur, might still have bugs in its code? The most tantalizing clue lies in the reset interval itself. 76 years isn't arbitrary. It's a timescale that mirrors certain celestial cycles, like the orbital periods of binary stars or the spin rates of pulsars. This synchronicity hints at an underlying mechanism, a hidden clockwork ticking beneath the surface of reality. Whether natural or something beyond our current physics, the glitch in the matrix forces us to confront a humbling possibility, that some corners of the cosmos operate on rules we haven't even begun to decipher. And until we do, NGC 1277's looping stars will keep reminding us sometimes the universe doesn't just break its own rules, it rewrites them. Hovering near the edge of NGC 1277, a cosmic silhouette stops astronomers mid-sentence, a nebula so uncannily humanoid, it's been nicknamed the Galactic Mermaid. From certain angles, the gas formation appears to stretch languidly through space, its arms trailing behind a distinct torso and tail, as if frozen mid-swim through the interstellar void. The resemblance is so striking, it's hard not to wonder, are we seeing the universe's version of a sculpture or just another trick of the light? This is where the science of pareidolia, the human brain's tendency to find familiar shapes in randomness, collides with genuine cosmic mystery. We've all seen it before, the face on Mars, the celestial dragons in nebula clouds, even the moon's man. Our minds are wired to seek patterns, especially ones that resemble living forms. But the Galactic Mermaid pushes pareidolia to its limits. Unlike vague shapes that require squinting and imagination, this structure's contours are eerily precise, maintaining their form across multiple wavelengths of light. Infrared, radio, and optical telescopes all capture the same silhouette, ruling out the chance it's just a fleeting illusion of dust and shadow. What makes this nebula so provocative isn't just its shape, it's the physics behind its persistence. Most gas clouds are shredded by stellar winds or torn apart by gravity within millennia. Yet the mermaid's structure has held its form for at least 100,000 years, defying the chaotic forces that should have scattered it eons ago. Some researchers suggest magnetic fields might be acting like invisible wires, stitching the gas into this peculiar shape. Others point to the faint gravitational pull of nearby objects, perhaps a cluster of rogue planets or a dark matter filament holding the nebula in this uncanny pose. Then there's the wild card. Could this be something more than natural? The idea of deliberate structure raises eyebrows, but the universe has surprised us before. Certain types of focused energy, like the jets from pulsars or black holes, can sculpt gas into unexpected forms. If a high-energy beam punched through this region long ago, it might have carved the nebula like a cosmic chisel. There's even a fringe hypothesis that the mermaid is a kind of message in a bottle, a naturally occurring alignment that just happens to mirror a shape meaningful to us. After all, in a universe infinite in its variety, even the most improbable coincidences must occur somewhere. The real test lies in the details. If the nebula's structure follows known physical laws, if its density gradients and magnetic alignments explain its form, then it's a masterpiece of nature's artistry. But if closer inspection reveals patterns that defy conventional models, the Galactic Mermaid might become more than a curiosity. It could be a benchmark, a cosmic Rosetta Stone challenging us to distinguish between coincidence and intention in the vast, whispering darkness of space. One thing's certain, in a galaxy already overflowing with anomalies, this shimmering figure reminds us that the universe's creativity knows no bounds, and that sometimes the most profound mysteries wear familiar faces. Tucked away in the outer reaches of NGC 1277, a patch of darkness defies every law of cosmic illumination, a void that devours light without the crushing grip of a black hole. Unlike the inky blackness of space punctuated by distant stars, this anomaly is something far stranger. Light doesn't merely pass through it unseen, it vanishes entirely, swallowed without a trace. Telescopes trained on this region detect no reflection, no scattered photons, not even the faintest thermal signature. It's as if the void isn't just dark, it's actively hungry. The first clue to its nature came when astronomers noticed stars disappearing behind it. Normally, when a star passes behind interstellar dust or gas, its light dims predictably, like a lamp seen through frosted glass. But here, stars wink out abruptly, their light cut off as if by a cosmic guillotine. Even more baffling, the void emits nothing in return. Black holes, for all their light-trapping power, at least betray their presence with X-rays or gravitational lensing. This thing is silent, leaving no fingerprints behind. So what could possibly explain a light-eating void that's not a black hole? One theory points to an exotic form of matter, something denser than neutron stars, yet without the singularity at its core. Theoretical particles like quark nuggets or strange matter could, in theory, pack enough mass to bend light paths without collapsing into a black hole. Picture a cosmic sponge soaking up photons not through gravity, but through some unseen interaction with the fabric of reality itself. Another tantalizing possibility involves dark matter in a configuration we've never observed. Most models assume dark matter is diffuse, spread thinly across galaxies. But what if it can clump into ultra-dense structures, forming shadows so thick that light can't penetrate? These hypothetical dark matter stars or black mirrors would absorb all incident radiation, leaving behind perfect voids. Supporting this idea are faint gravitational ripples detected near the anomaly's edges, hints of something massive lurking just beyond our instrument's reach. Then there's the wild card, a cosmic defect left over from the Big Bang. If space-time itself twisted into a knot during the universe's birth, it might have created regions where the rules of electromagnetism don't apply. In such a place, photons could simply cease to exist, their energy diverted into some hidden dimension or converted into an undetectable form. It's a radical idea, but in a galaxy already brimming with anomalies, no theory is too far-fetched. What makes this void so revolutionary isn't just its defiance of physics, it's the questions it forces us to confront. If light can disappear without a black hole's help, what other invisible phenomena might we be missing? Are there more of these voids lurking unnoticed in the cosmic shadows? NGC 1277's light-eating enigma doesn't just challenge our understanding of darkness, it redefines it, proving once again that the universe holds mysteries darker than the blackest night. In the swirling depths of NGC 1277, time itself seems to bow to an unseen conductor, a cluster of pulsars ticking in flawless harmony across thousands of light years. These cosmic lighthouses, typically erratic in their rhythms, here pulse with such precise alignment that their beats could set the universe's metronome. Astronomers first noticed the anomaly when radio telescopes picked up their signals, not the usual staccato randomness of isolated neutron stars, but a chorus of clicks so synchronized they seemed engineered. What makes the celestial clock so baffling isn't just the synchronization, it's the scale. Pulsars are nature's most accurate timekeepers, spinning with atomic clock regularity as they beam radiation across space. Yet even slight differences in mass, rotation, or magnetic fields should make their rhythms diverge over time. For multiple pulsars to maintain perfect alignment across such vast distances defies every known law of celestial mechanics. It's like scattering a dozen grandfather clocks across a continent and returning centuries later to find them all striking the same second. Theories attempting to explain this cosmic orchestra range from the elegant to the extraordinary. One possibility involves an invisible scaffold of dark matter, its gravitational influence acting like a master pendulum that nudges the pulsars into sync. If dark matter in this region is arranged in a rare, lattice-like structure, its precise gravitational tugs could coordinate the pulsar's spins like fingers tuning the strings of a harp. Another idea points to primordial gravitational waves, ripples from the Big Bang itself, that might have imprinted a shared rhythm on these stars during their formation, locking them into harmony like musicians attuned to the same eternal vibration. But the most tantalizing hypothesis challenges our very understanding of neutron stars. What if these pulsars aren't independent objects at all, but interconnected limbs of a single hypermassive structure? Some models suggest that in the early universe, superdense neutron star clusters could have formed, their cores linked by quantum entanglement or exotic matter. Though such objects should have collapsed into black holes, NGC 1277's unique environment, perhaps shaped by its monstrous central black hole, might have preserved them as relics of a physics we've yet to comprehend. The implications ripple far beyond curiosity. If pulsars can synchronize naturally across such distances, it could revolutionize how we navigate the cosmos, turning these celestial clocks into a galactic GPS. Conversely, if their harmony hints at new physics, we might be glimpsing a deeper layer of reality, one where the universe's building blocks communicate in ways Einstein never dreamed. Every tick of the celestial clock is a reminder, even in the chaos of space, there are patterns waiting to be heard, and in their rhythm we might just find the key to time itself. Deep within the heart of NGC 1277, a cosmic paradox rages, a brilliant jet of pure annihilation, spewing antimatter into the void with the fury of a runaway furnace. Unlike the usual plumes of superheated gas seen in other galaxies, this is something far more volatile, a fountain of positrons streaming from the galaxy's core at near light speed, each particle a mirror image of the electrons that make up our everyday world. Where these antimatter torrents meet normal matter, they erupt into bursts of gamma radiation so intense they outshine entire star clusters. It's as if the galaxy is carving its name into the cosmos with a blade of pure energy, etching a deadly signature across the darkness. The existence of such a fountain shouldn't be possible. Antimatter is notoriously fleeting in our universe, annihilating on contact with normal matter in a flash of light. Yet here it flows relentlessly, defying the odds like smoke rising against the wind. The secret lies in its origin, the supermassive black hole at NGC 1277's center. As matter spirals toward the event horizon, unimaginable forces tear particles apart, creating pairs of matter and antimatter. Normally, these pairs would destroy each other instantly, but in this case, the black hole's extreme rotation flings positrons outward like a cosmic slingshot, hurling them clear before annihilation can occur. The dangers of such a phenomenon are as awe-inspiring as they are terrifying. A single gram of antimatter meeting matter releases energy comparable to a nuclear bomb. The fountain's output thousands of tons per second. If this jet were pointed toward Earth, the resulting gamma-ray bursts would sterilize our planet in moments. Even at NGC 1277's distance, telescopes detect its fury as a constant flicker of high-energy light, a reminder of nature's capacity for destruction on scales we can barely fathom. Yet for all its lethality, the antimatter fountain holds tantalizing promise. Antimatter is the universe's most efficient fuel, capable of propelling spacecraft to relativistic speeds if harnessed. Here, nature has built its own particle accelerator, a natural lab for studying physics at energies impossible to replicate on Earth. Some theories even suggest such jets could seed the cosmos with rare elements, forging gold and platinum in their wake like cosmic alchemists. What makes this fountain truly revolutionary, though, is the questions it forces us to confront. Why hasn't all antimatter vanished since the Big Bang? Could pockets of it still lurk in the voids between galaxies? NGC 1277's deadly geyser isn't just a spectacle, it's a challenge, daring us to rethink the universe's most fundamental symmetries. And as we stare into its brilliance, we're reminded, sometimes the most profound truths are written in the language of annihilation. Amid the swirling chaos of NGC 1277, a star burns quietly, not with the searing heat of nuclear fusion, but with an eerie, cool luminescence that defies the laws of stellar physics. Astronomers call it the frozen star, and it's unlike any sun ever discovered. While every other star in the cosmos radiates both light and heat, this celestial anomaly glows with brightness alone, as if someone flipped a cosmic switch and left only the illumination intact. Imagine stepping into a room lit by a bulb that casts no warmth. No matter how close you get, the air stays cold. That's the unsettling reality of this stellar enigma. What makes the frozen star so baffling isn't just its lack of heat, it's the clarity of its light. Spectroscopic analysis reveals the same elemental signatures you'd find in an ordinary star: hydrogen, helium, traces of heavier metals. But the temperatures don't align. A typical star with this composition should blaze at thousands of degrees, its surface churning with plasma. Instead, the frozen star registers barely above absolute zero, colder than the void between galaxies. It's as if the laws of thermodynamics simply don't apply here, or worse, as if something is actively siphoning away the star's heat, leaving only its ghostly glow behind. One radical theory suggests this could be a failed star, a celestial object that never ignited properly. In standard stellar evolution, clouds of gas collapse under gravity until nuclear fusion kicks in, turning them into furnaces. But what if this one stalled mid-formation, freezing in a state between gas cloud and true star? The problem is, even failed stars' brown dwarfs emit residual heat from their gravitational contraction. The frozen star's absolute coldness rules that out. Another possibility is far stranger: a star made of exotic matter. Certain theoretical particles, like cue balls or strangulets, could theoretically clump into stellar-scale objects that emit light through mechanisms unrelated to heat. Picture a colossal crystal, its structure vibrating at frequencies that produce visible light without the usual thermal side effects. If such matter exists, it might explain the frozen star's impossible glow, but it would also mean we're looking at an entirely new class of celestial object, one that rewrites the textbook definition of a star. Then there's the dark matter angle. If a dense knot of invisible particles somehow intertwined with this star, it might absorb all thermal energy while leaving light unaffected. Think of it as a cosmic heat sink, silently draining warmth into some unseen dimension. Supporting this idea are faint gravitational ripples detected around the star, hints of an unseen mass tugging at the fabric of spacetime. But the most unsettling explanation is also the simplest: that we're witnessing the aftermath of a stellar hijacking. If an advanced civilization could harness a star's energy, they might leave behind a hollowed-out shell, a cold, luminous husk stripped of its heat. While this veers into science fiction, the universe has surprised us before. After all, if stars can flicker and black holes can sing, why couldn't a star be frozen in time? Whatever the truth, the frozen star forces us to confront how little we truly understand about the cosmos. In a universe where the impossible keeps becoming reality, this icy sentinel stands as a silent challenge, a reminder that even the most familiar objects can hide secrets that defy our boldest theories. And until we unravel its mystery, it will keep shining coldly in the dark, a beacon for the questions we've yet to ask. Among the countless wonders of NGC 1277, one structure stands out not for its brightness or strangeness, but for its eerie sense of connection, a point where galactic filaments converge with unnatural precision. Dubbed the cosmic web node, this intersection isn't just a random tangle of stellar threads. It's a crossroads, a junction where the hidden scaffolding of the universe reveals itself in stark relief. Most galaxies are connected by these faint, wispy filaments, strands of gas and dark matter stretching across the cosmic void. But here, they don't just meet. They knot together in a gravitational handshake so tight, it warps the very fabric of space around it. Picture the universe on its grandest scale, not as a scattering of isolated galaxies, but as an intricate tapestry woven together by these gossamer threads. The vast cosmic web binds everything from the smallest dwarf galaxies to the largest superclusters in an invisible lattice of gravity. Normally, these filaments are delicate, diffuse, barely detectable except through their subtle pull on surrounding matter. But at this node in NGC 1277, something extraordinary happens. The filaments thicken, their gravitational influence intensifying until they form a visible nexus, a point where the universe's hidden architecture briefly steps into the light. What makes this node so significant isn't just its rarity, it's the way it challenges our understanding of cosmic evolution. According to simulations, such dense intersections should only occur near the universe's most massive galaxy clusters, where gravity's pull is strong enough to compress the web into tight knots. Yet here it is, nestled in a relatively unremarkable galaxy, defying the odds. Some researchers suggest this could be a fossil imprint, a relic from a time when NGC 1277 sat at the heart of a far larger structure, since dispersed by cosmic expansion. Others propose a more radical idea, that dark matter here behaves differently, clumping in ways that amplify the web's structure against all expectations. Then there's the mystery of what flows through these filaments. The cosmic web isn't just a static scaffold, it's a highway funneling gas and even entire galaxies along its strands. At this node, the flow isn't just steady, it's turbulent, as if matter from multiple directions is colliding in a slow-motion traffic jam. Spectroscopy reveals streams of hydrogen and helium surging inward, compressed and heated by the gravitational tides, while dark matter's invisible currents twist and churn beneath the surface. It's a cosmic whirlpool, drawing in material from across millions of light years, feeding the galaxy in a way that could explain its other anomalies. But the most tantalizing possibility is that we're seeing a snapshot of creation itself. In the early universe, nodes like these were the seeds of everything, the points where matter first pooled, giving rise to galaxies and clusters. Most have long since been swallowed by the structures they birthed, but this one persists, frozen in time. If so, NGC 1277 isn't just a galaxy with strange objects. It's a living museum offering a glimpse into the forces that shape the cosmos. And as we study this tangled knot of filaments, we're not just exploring a single anomaly. We're tracing the threads of the universe's grand design, one intersection at a time. Among the 30 strange objects in NGC 1277, none sparks the imagination quite like Object 25, a flickering anomaly that behaves less like a natural celestial body and more like a cosmic light switch. Every 11 months, like clockwork, its brightness plummets by nearly 40%, staying dim for exactly 27 days before snapping back to full intensity. This isn't the gradual dimming of a dusty star or the erratic flicker of a dying sun. It's a precision-cut shadow, a pattern so deliberate it begs the question, are we witnessing the universe's first confirmed Dyson sphere? The concept of a Dyson sphere, a hypothetical megastructure built by an advanced civilization to harness a star's energy, has long lived in the realm of science fiction. Theorized by physicist Freeman Dyson in the 1960s, these constructs would envelop a star entirely or in part, capturing its light for unimaginable technological needs. Natural phenomena rarely mimic such artificial regularity, which is why Object 25's rhythmic dimming sent shockwaves through the astronomy community. The numbers are almost too perfect. The 11-month cycle aligns neatly with a conceivable construction timeline for an orbiting swarm of energy-collecting panels, while the 27-day blackout could represent a maintenance or repositioning phase. But before we leap to conclusions, the skeptics raise compelling counterpoints. Some argue the dimming could stem from an unusually dense debris disk, a ring of planetary wreckage orbiting the star at a precise interval. Others point to exotic stellar physics, perhaps a star with a magnetic field so intense it periodically traps its own light, creating artificial-looking eclipses. Then there's the rogue planet theory, a gas giant with a highly elliptical orbit, trailing a thick shroud of moon-sized asteroids that blot out the star's light at predictable intervals. Each explanation has merit, but none account for the sheer precision of the timing or the absence of residual heat, a telltale sign of obstructing matter that should glow in infrared. The most tantalizing clue, though, lies in the light itself. When a star is partially obscured by natural means, certain wavelengths are blocked more than others, leaving a spectral fingerprint. Object 25's dimming, however, is eerily uniform across all wavelengths, exactly what you'd expect if something flat and artificial, like a solar panel array, were passing in front of it. It's the difference between squinting through frosted glass and flipping a light switch. One scatters, the other simply cuts off. So where does that leave us? The honest answer: at the edge of a paradigm shift. If this is natural, it's a phenomenon we've never observed before, rewriting the rules of stellar behavior. If it's artificial, the implications are staggering, not just for NGC 1277, but for our place in the cosmos. Either way, Object 25 forces us to confront a humbling truth. The universe is far stranger than we've dared to imagine, and sometimes the line between science and science fiction blurs in the flicker of a distant star. Hidden among the chaos of NGC 1277 lies a cosmic funhouse mirror, a gravitational lens so baffling it warps the very fabric of reality into shapes that shouldn't exist. Normally, these natural telescopes bend light predictably, magnifying distant galaxies into elegant arcs and rings as Einstein's theory dictates, but this lens twists those rules into knots. Instead of smooth curves, it fractures background starlight into jagged, kaleidoscopic patterns, as if spacetime itself has cracked under some unseen pressure. The anomaly begins with its location. Gravitational lenses typically form around massive galaxy clusters, where the combined heft of thousands of stars and dark matter warp light like water, distorting a straw. Yet this lens hovers alone in a relatively sparse region of NGC 1277, anchored by something too faint to see. When astronomers calculated the mass required to create such extreme distortions, the numbers didn't add up. The visible matter nearby, a smattering of old stars, wispy gas clouds, couldn't possibly account for the lensing effect. It's like finding a canyon carved by an invisible river. Then there's the lensing pattern itself. Most cosmic lenses stretch background galaxies into symmetrical smears, like taffy pulled evenly from both ends. This one shatters them. Light from distant objects splinters into disjointed fragments, some magnified tenfold while others vanish entirely. The effect resembles peering through shattered glass, with each shard bending reality at a different angle. One particularly eerie snapshot even captured the same galaxy appearing twice in the same frame, once flattened into a razor-thin line, the second time bloated into a warped oval, as if the universe itself couldn't decide how to distort it. Dark matter seems the obvious culprit, but there's a twist. When researchers mapped the lens's gravitational field, the distribution didn't match any known dark matter profile. Instead of a smooth halo, the data suggested something jagged, a lattice of dense knots interconnected by near-empty voids, like a spiderweb woven from gravitational glue. Some theorists speculate this could be evidence of sticky, dark matter, a hypothetical variant where particles clump more aggressively than standard models predict. Others propose an even stranger idea, that we're seeing the imprint of a cosmic string, a hypothetical defect in space-time left over from the Big Bang. These ultra-dense filaments, thinner than an atom but stretching across galaxies, could theoretically warp light in bizarre, asymmetrical ways, yet the most tantalizing clue lies in the time delay. When light takes multiple paths around a lens, some photons arrive later than others, a telltale signature of relativity in action. Here, the delays don't align with the lens's visible structure. Some photons dawdle decades longer than expected, as if they detoured through hidden dimensions. It's a discrepancy that hints at forces beyond our current physics, perhaps even modifications to Einstein's theory of gravity itself. What makes this lens so revolutionary isn't just its defiance of expectations, it's the way it forces us to question the tools we use to map the invisible. If gravity can sculpt light into shapes this unnatural, what else have we misunderstood about the cosmos? Every twisted beam of starlight from NGC 1277's rogue lens is a challenge, daring us to look deeper, and to accept that some cosmic mirrors don't just distort what we see. They shatter our understanding of how reality works. At first glance, Object 27 seems ordinary, just another quiet corner of NGC 1277, where dim stars drift lazily against the cosmic backdrop. But point a telescope toward this patch of sky, and something impossible reveals itself. Flashes of light with no logical source, flickering like echoes of explosions that never were. These aren't the predictable remnants of supernova or the fading glow of stellar collisions. They're ghostly reverberations, replaying bursts of energy that, by all accounts, should have flared and vanished billions of years ago. Yet here they are, pulsing across the void as if time itself has come unstitched. The phenomenon, dubbed the Echo Galaxy, operates on a principle as baffling as it is beautiful. When a star explodes, its light races outward in all directions, some reaching us directly while other photons bounce off interstellar dust, arriving years or even centuries later as faint light echoes. But in this case, there's no record, no ancient supernova, no cataclysm, to explain the echoes. It's as if the galaxy is replaying lost moments, flashes of violence erased from cosmic history. Telescopes scanning the area find no neutron stars, no black holes, none of the usual corpses left behind by stellar deaths, just the echoes repeating like a skipping record in the dark. One theory suggests we're witnessing the aftermath of a collision between parallel universes, a hypothetical event where another reality's supernova bled through a crack in space-time, imprinting its light here like a phantom limb. The idea sounds like science fiction, but the math holds a sliver of plausibility. Quantum physics allows for the possibility of multiverses, and if two bubble universes briefly brushed against each other in the distant past, the energy transfer could have left behind these eerie afterimages. It's a stretch, but so is the alternative that our understanding of time is fundamentally flawed. Then there's the dark matter angle. If a dense knot of invisible particles lurks here, its gravity might warp light so severely that photons take centuries-long detours, creating delayed apparitions of events we missed. Picture a cosmic hall of mirrors where light ricochets off unseen surfaces, tricking us into seeing the past as present. Supporting this idea are strange gravitational ripples detected near the echoes, hints of mass where none can be seen. But the most unsettling possibility, that the Echo Galaxy isn't replaying the past, it's previewing the future. Some models of quantum mechanics suggest time isn't linear, but a tangled web where cause and effect can loop back on themselves. If that's true, these flashes might be cosmic spoilers, glimpses of supernova destined to explode centuries from now, the implications are dizzying. If light can arrive before its source event, does time even flow the way we think? Or is it merely another dimension as malleable as space? NGC 1277's Echo Galaxy doesn't just challenge our understanding of supernova, it forces us to confront the fragile nature of time itself. In a universe where light can outrun its origins and history flickers like a candle in the wind, perhaps the past isn't written in stone. Maybe it's just another echo waiting to be heard. Nestled deep within NGC 1277, there's a place where the universe's most confounding rule isn't just a theory, it's a spectacle. Welcome to the quantum entanglement zone, a region where particles separated by light years move in perfect, instantaneous sync, as if bound by invisible threads. This isn't just a laboratory curiosity scaled up. It's nature's own demonstration of quantum entanglement operating on a cosmic stage, defying our classical understanding of space and time. Picture this: two electrons born from the same quantum event, one drifting near the zone's edge, the other flung halfway across the galaxy. According to everything we know, no signal can travel faster than light. Yet the moment one electron's spin is measured, its distant twin instantly mirrors that spin, no matter the distance. In labs on Earth, we've entangled particles across mere miles. Here, it's happening across distances so vast, it tears at the fabric of Einstein's spooky action at a distance. The implications are staggering. If entanglement can persist over interstellar scales, it suggests the universe might be far more interconnected than we ever imagined. But what makes this zone truly revolutionary isn't just the phenomenon, it's the environment sustaining it. Unlike Earth's delicate quantum experiments, which collapse at the slightest interference, this region somehow shields entangled states from decoherence. Magnetic fields woven through the area appear to act like cosmic Faraday cages, protecting the quantum links from disruptive noise. Even more intriguing, the entanglement isn't limited to particles of the same type. Protons, photons, even entire atoms are caught in this dance, their properties locked in unison across the void. It's as if the zone is a living blueprint for a quantum network writ large. Now imagine harnessing this for communication. Today's interplanetary signals crawl at light speed, making real-time chats with Mars a 20-minute lag fest. But entangled particles don't care about distance, their connection is instantaneous. Build a device that encodes data in one particle state, and its twin light years away reflects that change in lockstep. No latency, no bandwidth limits, just pure, faster-than-light information transfer. The catch: we'd need to read the particles without breaking their entanglement, a problem physicists are still scratching their heads over. Yet here in NGC 1277, nature's already solved the stability puzzle. Studying this zone could hand us the missing manual for quantum tech's next leap. Of course, skeptics whisper of cosmic trickery. Could the particles merely seem entangled, their sync a fluke of some deeper, unseen force? Alternate theories propose exotic physics, like hidden dimensions acting as shortcuts between points in space, or dark matter mediating connections we can't yet detect. But every test run so far only tightens entanglement's grip on reality. The zone's particles pass every quantum loophole, no hidden variables, no sneaky signals, just the universe bending its own rules. What's truly exhilarating is the scale of possibility. If quantum links can span galaxies here, why not elsewhere? Are these zones rare jewels, or have we just missed them in the cosmic noise? For now, NGC 1277's quantum entanglement zone stands as both a riddle and a revelation. It's a place where the universe whispers its secrets not in light or gravity, but in the silent, perfect sync of particles dancing across the void. A reminder that the threads binding reality might be far stranger and far more beautiful than we've dared to dream. Rising from the cosmic dust of NGC 1277 like an obsidian skyscraper, Object 29 shatters all expectations of natural form. The celestial monolith, as astronomers have nicknamed it, is a stark rectangular structure stretching nearly 4 light-years in length, its razor-sharp edges defying the universe's preference for curves and chaos. Where planets, stars, and galaxies sculpt themselves through gravity's gentle pull or violent collisions, this monolithic slab stands unnervingly precise, as if chiseled by some unseen hand. Most cosmic formations owe their shapes to turbulence. Nebulae swirl like spilled paint, star clusters bloom in fractal patterns, but the monolith, its 90-degree angles and geometric perfection suggest a different origin story entirely. First spotted in Hubble data as an anomaly in the starlight, a patch of darkness too uniform to be a dust cloud, the object's true nature only became clear when radio telescopes mapped its silhouette. Unlike the jagged shadows cast by asteroids or comets, this was a perfect rectangle, blocking all light behind it with mathematical precision. At cosmic distances, that kind of symmetry is statistically improbable to the point of absurdity. Even crystalline structures in space, like diamond planets or neutron star crusts, form irregularly under extreme pressures. The monolith's flawless geometry hints at either a freakish natural accident or a deliberate design, and the universe rarely deals in accidents this precise. Then there's the composition. Spectroscopic analysis reveals the monolith isn't just empty space. It's lined with an ultra-dense lattice of metallic hydrogen, a form of matter typically found only in the cores of gas giants. Under normal conditions, metallic hydrogen decays instantly outside extreme pressure, yet here it persists, stabilized by some unknown mechanism that leaves physicists scrambling for explanations. Some suggest the structure might be encased in a shell of exotic matter, perhaps strange quarks or a Bose-Einstein condensate, acting like cosmic epoxy to maintain its impossible form. Others propose it could be a fragment from a higher dimensional object, its unnatural angles the result of dimensions we can't perceive intersecting with our own. But what truly chills the spine is its movement or lack thereof. While everything in a galaxy rotates, orbits, or drifts, the monolith remains fixed relative to NGC 1277's core, resisting the gravitational tides that should have shredded it eons ago. It's as if anchored to something beyond our perception, a cosmic piton driven deep into the fabric of space-time. This defiance of orbital mechanics has led to wild speculation. Could it be a marker, a beacon, or even a structural support for something larger? Ancient cultures erected standing stones to align with celestial events. Perhaps this is the universe's version, placed with purpose we've yet to decipher. Of course, skeptics argue for natural, if extraordinary, explanations. Certain plasma formations in laboratory settings can briefly exhibit geometric shapes under electromagnetic stress. Could the monolith be a scaled-up version, frozen in time by NGC 1277's unique magnetic environment? Or might it be the shadow of a black hole's accretion disk, warped by gravity into an illusion of right angles? Yet these theories struggle to explain the object's stability or its metallic hydrogen heart. The most tantalizing question remains: if the monolith is artificial, who or what built it? The idea of ancient alien megastructures isn't new, but always lingered in the realm of hypothesis. Here we might have our first tangible candidate. Imagine a civilization so advanced they could forge celestial architecture on a scale that outlasts stars. Or consider an even wilder possibility, that the monolith isn't built at all but grown, a self-assembling structure birthed from physics we've yet to discover. As telescopes continue to probe this cosmic oddity, one thing becomes clear: whether accident or artifact, the celestial monolith forces us to confront the limits of our understanding. In a universe where black holes sing and stars freeze solid, perhaps the greatest surprise is that we're still shocked when the cosmos throws us a curveball, especially when that curveball is perfectly rectangular. Deep within the swirling core of NGC 1277, something pulses with the steady rhythm of a sleeping giant, a cosmic heartbeat throbbing across the electromagnetic spectrum. Every 11 hours and 23 minutes, like clockwork, the galaxy's center releases a burst of energy so precise it could set your watch. Unlike the chaotic eruptions of quasars or the random flickering of black holes, these pulses rise and fall with metronomic consistency, as if the universe itself is tapping its fingers against the fabric of spacetime. The first clue to this anomaly's strangeness lies in its range. Most astrophysical pulses are confined to specific wavelengths: gamma rays from collapsing stars, radio waves from spinning pulsars. But this signal blankets the spectrum, from low-frequency radio up to high-energy X-rays, as if the source is orchestrating a symphony of light. Even more puzzling is the pulse shape, a rapid crescendo followed by an equally sharp decay, like the flash of a lighthouse cutting through fog. Natural phenomena rarely exhibit such clean, repeating waveforms without some form of degradation over time. Yet here, the signal has persisted without variation for every observed cycle since its discovery in 2019. So what could possibly drive this celestial metronome? One leading theory points to the galaxy's supermassive black hole, but with a twist. While black holes are notorious for their chaotic appetites, this one might be feeding in an unusually orderly fashion. Imagine a star trapped in an elliptical orbit, swinging close enough to have its outer layers stripped away during each pass. As the stolen gas spirals toward the event horizon, it could heat up and flare predictably, like logs being tossed into a furnace at regular intervals. The 11-hour cycle might correspond to the star's orbital period, with each close approach triggering a fresh burst of accretion-powered fireworks. Then there's the neutron star hypothesis. These ultra-dense stellar corpses often pulse with clockwork precision as they spin, but typically on timescales of milliseconds to seconds, not hours. For a neutron star to slow its spin enough to match this signal would require impossibly strong magnetic braking, or perhaps an exotic state of matter in its core that resists the usual spin-down mechanisms. Some theorists speculate we might be looking at a new class of slow pulsars, objects predicted by models but never before observed. But the most tantalizing possibility involves something far stranger, a naturally occurring cosmic engine. Certain unified field theories predict that extreme gravitational environments could excite vibrations in spacetime itself, creating standing waves that pump energy outward in rhythmic bursts. If NGC 1277's black hole is spinning at just the right frequency, and if the surrounding plasma is dense enough to act as an amplifier, the entire system might resonate like a struck bell ringing across the light years. What makes this cosmic heartbeat truly revolutionary isn't just its regularity, it's the way it challenges our assumptions about how energy behaves in extreme environments. In a universe dominated by entropy and chaos, such perfect rhythm hints at undiscovered laws, at symmetries hidden beneath the turbulence. Every pulse is a reminder that even in the darkest corners of the cosmos, order can emerge, if only we know how to listen. NGC 1277 isn't just a galaxy, it's a cosmic hall of mirrors, reflecting back every assumption we've ever made about the universe and warping it into something unrecognizable. From its 17 billion solar mass black hole to the ghostly whispers of the quantum ripple, this galactic rebel has rewritten the rules so many times, the rulebook itself might need a rewrite. Think about it, a star that shines without heat, a nebula that vanishes on schedule, a black hole that hums in perfect pitch. These aren't just anomalies, they're cosmic mutiny, each one a deliberate challenge to the laws we thought were set in stone. Take the celestial monolith, a structure so geometrically perfect, it looks carved by celestial engineers, or the phantom satellite hiding in plain sight, pulsing infrared like a coded message. Even the galaxy's heartbeat, ticking with 11-hour precision, defies the chaos we expect from supermassive black holes. And let's not forget the Echo Galaxy, replaying stellar explosions like a cosmic record stuck on repeat. Every corner of NGC 1277 whispers the same unsettling truth. The universe is far stranger, far more inventive than our textbooks dared to suggest. But here's the real kicker: none of these objects exist in isolation. They're part of a tangled web of defiance. The frozen star's icy glow might be linked to the quantum ripple's subatomic shivers. The antimatter fountain's deadly jet could be feeding the cosmic tornado's endless spin. Even the invisible wall, that perfect sphere of nothingness, might be the key to why the galaxy's dark matter clumps into filaments instead of halos. Together, they paint a picture of a universe where the rules aren't just flexible, they're optional. So what's next? Every mystery in NGC 1277 is an invitation to question, to explore, to rethink what's possible. Maybe you've got a theory about the glitch in the Matrix's looping stars or the galactic mermaid's impossible silhouette. Drop it in the comments. Let's unravel this cosmic puzzle together. And if you're craving more mind-bending space mysteries, hit subscribe, because one thing's certain: the universe isn't done surprising us, not even close.